My name is Allan Guymon, and I am one of the co-leads for the Polymers for Additive Manufacturing. What I do, I work with photopolymerization, which is using light to make large molecules polymers. A lot of times that's with coatings. We do biomaterials. We work with a lot of companies. The vision of the EPSCoR is a little bit different in that we want to try to make things from more natural sources that's not traditionally used in our field. And so this has been a way for us to refocus and try to think of ways that we can do this in using organisms to make what we need to use, which can definitely be a challenge with even with traditional monomer systems that we use. In this case, we want to make monomers or initiators or other components for our additive manufacturing platforms using organisms. So that's been a lot of fun, refocusing and looking at things in a different route, a different way that we traditionally don't do. So it's been a lot of fun to think things differently. Yeah, it's funny you ask, because I just taught material science. And material science is all about metals, ceramics, polymers. And so we're making polymers for additive manufacturing for 3D printing. So I was actually able to bring in quite a few examples from things we talked about in developing natural systems or biologically based or bio-derived systems throughout the semester. That's been a lot of fun of talking about how how you make things and how we traditionally make them, but this is the route that hopefully will be more sustainable. So we have an Industry University Cooperative Research Center on photopolymerization. That's an NSF graduated center, so we've been working with NSF in different ways to advance photopolymerization. They realized that our research combined well with some of the other efforts in additive manufacturing. And then partway through the process, I was asked to be one of the co-leads, which is awesome. I'm actually going to take a step back. My main goal as a professor is to help students get a great education and opportunities to contribute beyond their degrees, whether it's a bachelor's degree or a PhD degree. It's not just a product base. The product really here is we're going to have great students that come out of this. And of course it's beyond that too. I mean, we do have goals that are related to the project where we are going to make monomers, we are going to make initiators, we're going to make materials that would be traditionally made from petrochemicals, and we're going to have them produced by different organisms and being able to use those to enhance the viability of additive manufacturing for more robust applications, to be very honest. But the students are the key here. So without the students, none of this works. Sure, I think that we will have established multiple collaborative groups that can go on and compete for other awards, whether they're engineering research centers, whether they're other collaborative efforts through different agencies other than NSF. But again, more so, it is a lot of great students. They're going out there that through this program, through the support that we've received, have amazing PhDs that then go out and contribute. Something I didn't anticipate in all of this is I've really got to enjoy and become friends with many of the other people that I really didn't know that well at the start of this process. There's a lot of good people in our field and a lot of great ideas and thoughts. We're doing this, again, part of this is to develop and enhance competitiveness of what we do in the state of Iowa, but it's also understanding there's a lot of good things going on already that we can build upon, and certainly have just enjoyed the associations that we've been able to establish through the grant.